All right, so this is 8.1, distribution of a sample mean. My book, look for something real quick. But the sampling distribution of a statistic is a probability distribution for all possible values of a statistic computed from a sample size of n. So, we're just doing some background setup before we actually get to the calculation. The sampling distribution of the sample mean x bar is a probability distribution of all possible values of the random variable x bar computed from a sample size n from a population with mean mu and standard deviation sigma. All right, suppose that a simple random sample size n is drawn from a population with mean mu and standard deviation sigma. The sampling distribution x bar has a mean of, mu, whatever that population mean is, will be the mean of your sampling distribution. And your standard deviation will be the standard deviation of your sample, of your population over the square root of n. So when we put numbers on it, we'll be able to make that connection a little better. Excuse me. All right. The standard deviation of the sampling distribution is called the standard error of the mean.
I'm okay. Yeah.
Okay. And then if a random variable x is normally distributed, the sampling distribution of the sample mean x bar is normally distributed. So that means we can use our z-scores. So going back to our z-score charts, being normally distributed means that allows us to use our z-scores and our z-score charts. So that's why that's important.
Okay.
All right. Anybody still copying this first page before we go to the next one?
Yes.
All right. Not a problem.
Okay.
All right. Thank you. Anybody else before we go to the next page?
Pretty good.
All right. All right. Okay, so here we go. First example, the IQ X is of humans is approximately normally distributed with mean of 100, standard deviation of 15. Compute the probability that the simple random sample of size n equal to 10 results in a sample of mean greater than 110. So if you copy that for a second. All right, so the first thing you want to do is always write down your givens. So, oh, here we go. Then you guys can see my cursor. So right here, all the given information. Give us our mean is 100, standard deviation is 15, sample size n is 10, and the values question, our x bar, our sampling, our distribution thing that we're measuring, we have 110. So we want to know if you have a sample mean greater than 110. So that's where x bar comes into play. So the mean of our sampling distribution is going to be 100. So whatever your population mean is, that is the mean of your sampling distribution. Then the standard deviation of your sampling distribution is going to be sigma 15 over the square root of 10, and that's 4.743. All right, questions on that?
No, I guess the only thing I would say is the 10 in a greater or a gosh, what is that? Trying to think of it. I can't think of it off the top of my head, but am I squaring it or anything?
Wait, well, you're taking the square root.
Yeah, yeah, okay, there I am. Okay. Okay, okay.
Yes, so yeah, that'll be the square root of that.
Okay, cool. Then we're good.
All right. So now notice it said we're gonna find the z-score. So the way we'll do that, we're doing x bar minus the mean of your sampling distribution, which is what we calculated to be 100, or found to be 100. Then the standard deviation of that, of the sampling distribution, which is at 4.743. And that's 2.11. Don't forget z-scores, we round to 2 decimal places. Once you have your z-score, you go to your z-score chart. So don't forget, whatever we get from the chart is going to be less than . So if you want greater than, remember that's what we were asking for, greater than 110. So if we want greater than, we have to subtract it from 1. Subtract your chart value from 1, and that gives us 0.0174. And then, so our conclusion, the probability of obtaining a sample mean IQ greater than 110 from a population whose mean is 100 is 0.0174. All right. So once again, don't forget whatever value you pull from the chart is going to be less than. If you want greater than, you subtract it from 1. And that's how we got that answer. All right, questions before we go to the next one? All right. Anybody holding on to this page?
No, I'm okay.
All right. Let's go to page 3. There you go. So next one is the central limit theorem. It says regardless of the shape of the underlying population, the sampling distribution of X bar becomes approximately normal as the sample size n increases. Remember, being approximately normal matters because if it's normal, it's a normal distribution, then that means we can use our z-score chart and our z-scores. If the distribution of the population is unknown or not normal, then the distribution of the sample mean is approximately normal, provided that the sample size is greater than or equal to 30. All right, so we're looking for our sample size to be greater than or equal to 30 in order for us to assume that it's approximately normal.
I like your notes today too. I was gonna say
Oh
I
yeah,
like them, but this is cool too. Like it's just different, I guess. I don't know.
yeah. Cause see, I actually wrote them out this way when we first started the pandemic in the summer,
Oh,
but
really?
I didn't have the type of computer I had to be able to write on the screen. So that's
Oh,
why I wrote them on a note that I took pictures of and scanned it with my phone and then sent it to myself. And so it was a little different because I couldn't even magnify it. So they just had to have the whole sheet.
yeah, yeah,
They just had to have it like that, and then we just had
yeah,
to
yeah,
deal with
yeah.
it.
That's pretty cool though.
Yeah. So yep, yep, yep. All right. Anybody holding on to the beginning part?
Okay.
Good. All right. So here's the example. The mean weight gain during pregnancy is 30 pounds with a standard deviation of 12.9 pounds. Weight gain during pregnancy is skewed right. An obstetrician obtains a random sample of 35 low-income patients and determines their weight gain during pregnancy was 36.2 pounds. Does this result suggest anything unusual? So once again, give you a chance to write that out. All right. Next page. Anybody holding on to this before we go to the next page?
I'm okay.
1 second.
All right, got it 1 second. Not a problem. Just let me know.
You're good.
All right. Thank you. Wait for it to adjust. There we go. All right. So just like before, I want to write down the given information first. So population parameter was, or population mean was 30. Standard deviation of the population 12.9. And our sample size was 35. So remember, we needed our sample to be 30 or greater. So this one's 35, so we're good to go. Then X bar is going to be at 36.2. So the mean of our sampling distribution is going to be that 30. Whatever that population mean is, that's what that would be. Then the standard deviation of our sampling distribution is going to be the population standard deviation over the square root of the sample size. So that's what we have here. Give you a chance to write that out.
I'm okay.
All right, all right. So we're going to find our z-score. We have X bar, mean of our sampling distribution, and standard deviation. So same format, same process. 36.2 minus 30 over there, 2.180498. So how far you go out when your decimal is up to you. I normally go out at least 4. But the further you go out, the more precise your answer will be. I wouldn't round to 2 decimal places till you get to your final answer. That's when you do your rounding to 2 decimal places.
Right.
So that's 2.84. Go to the z-score chart, 0.9977. And once again, it represents less than. So here we look at our little note. Since we want to know how unusual this is, then we want to know the chance of it being greater than. So subtract it from 1. All right. So we got 0.0023. So this is unusual because the probability is less than 5%. So remember, that was our marker for unusual activity or unusual occurrence is that 5%, 0.05. And that 0.0023 is less than that. So that means this would be unusual. All right. Questions on that? So the process in this section will, be the same.
Right.
You get your mean, you get your standard deviation, you get your sample size, and then what value are you comparing, less than, greater than, that will be your X bar. Your mu, your standard deviation, not standard deviation, your mean of your sampling distribution will be the same thing as your population mean. Then the standard deviation of your sampling distribution will be your population standard deviation over the square root of your sample size. Once you establish those two pieces, then you can go ahead and find your z-score, go to your chart, and we talked about reading your z-score chart. And depending on what they ask you, if they ask you about less than, then that chart value will be your answer. But if it's greater than, you subtract it from 1. And that would be the process.
Okay.
All right, anybody holding on to this page?
Mm-mm.
Oh, okay. Well, that was it for 8-1.
That was it? Oh my gosh, that was really quick.
Yep. So we'll do 8-2 next class, and then we'll talk about how we're going to do this test.
Right.
Remember, we didn't do a proctor test last time because my math lab jacked this up.
Right.
So we are looking to do a proctor test this time. You will be able to use your notes if you like, and I will still offer you the makeup option. So excuse me. So we'll talk about those details, after we knock out 8.2 on next class, and when we'll actually be looking to take that test for those who are going to take it, proctored and and all that stuff like that. But any questions, concerns, or comments before we close today?
No, definitely once you get in the homework and try it out through some more stuff like that. But so far it's okay. It's like
right.
so far. I mean, so yeah.
All right.
Getting nervous, Mr. Tucker. We're coming to that end, y'all. Like
yep. All we have is
back to the end, but you know what I mean, you guys.
Well, all we have is a month left. You're right. I mean, we have enough time to get some stuff done, but we have enough time to be concerned if we don't have enough done. You know what I mean? So
yeah.
right there in that middle.
Mm-hmm.
So, all right, guys. So let's take advantage of our opportunities. Countdown time.
Yeah, literally.
And we're looking to close out on a good note. So if you guys have any questions, always feel free to email me or bring it to class next class. We'll have time because we're only doing one section, and we'll go from there.
Okay. Well, cool then. You guys
right.
have a good day.
All right. You take care.
All right. Thanks, Mr.
Thank
Tucker.
you.
You have a good day.
Thank you.
Bye.
Thank
Good
you.
day.
All
Bye,
right,
guys.
everybody have a good one. Take care.
Bye, y'all.